Okay, well, thank you very much, Jenny, and thank you very much for everybody else for joining in. So as Jenny indicated, I'm the science team chair for the US AMOC Science Team, or the chair of the executive committee, I guess. For those of you who are relatively new, the US AMOC Science Team consists of proposals that are funded by the 4 agencies and their divisions that are included here: NASA Earth Science Division, NOAA Climate Program Office, NSF Geosciences Program, and US Department of Energy Office of Science. So as such, US AMOC Science Team is an interagency program. So what I wanted to just briefly describe here or present here is a brief background on the science team, and I'll refer to it as ST, its history, objectives, and organization. I'll briefly summarize our recent activities. Of course, I wanted to show a few project highlights and finish with some thoughts for the future. I should also right away indicate that US AMOC Science Team, although it has the US in it, it has strong collaborations and partnerships with the international community, particularly with the UK RAPID program. And back in, I think, 2019 or so, or 2018 rather, it was decided that the science team will be sunsetting at the end of 2020. But because of the delays in our meetings and all the COVID situation, that sunsetting date has been extended to the end of 2022. So the US AMOC program was established, well, sort of, this is a brief history. Back in January of 2007, AMOC was identified as a near-term priority by the Joint Subcommittee on Ocean Science and Technology. Then in October of the same year, US AMOC implementation plan was released. And in March 2008, the US AMOC Science Team was formed. And again, as I said, it includes all of the proposals related to AMOC from the 4 funding agencies. Since 2009, we have had 6 national and 4 international meetings. And the international ones were essentially rotating between US and UK as part of the UK RAPID program. And 6, even though I say 6 national US AMOC Science Team meetings, these were all open to international participation as well. And I think, well, roughly about 200 proposals or projects were funded since the beginning of the US AMOC program. And if Jenny just before this meeting indicated that since 2018 or so, we have roughly 75 active AMOC-related funded projects from the 4 agencies. So the scientific objectives of the US AMOC program is given here. It concerns implementation and evaluation of AMOC observing system, assessment of AMOC state variability and change, assessment of AMOC variability mechanisms and predictability or prediction also, assessment of the role of AMOC in global climate and ecosystems, and finally, the 5th one is a relatively new objective. It got added maybe in 2018 or 2017, fostering cross-disciplinary collaborations between paleoscientists with the modern AMOC community. So this is our existing AMOC program organization. So there is the executive committee. So before I get to the executive committee, we have 5 task teams. And as I said, Paleo AMOC got added in about a few years ago. And the folks listed in red here are the current leadership or co-chairs of these task teams. The co-chairs of these folks, along with myself, actually form the executive committee of the US AMOC Science Team. So just to be clear, this is actually a rather broad program. The science team itself includes all the folks who are working on an AMOC-related project funded by those 4 agencies. So it's inclusive of PIs, co-Is, postdocs, and students. So it's not just the PIs of those projects. As such, it's a relatively large program. So since we knew back in 2018 that we were going towards sunsetting, we actually at that time at our meeting, we had come up with certain priorities that we needed to establish before the sunsetting of the program. And the primary goal here is, I wrote it in red, maintaining momentum beyond. And how can, I mean, clearly AMOC-related research is not just going to stop simply because this program is sunsetting. It's going to continue, but how can we essentially help with smooth continuation of the program? And we came up with sort of this handout. This was handed out to participants at that time, and I think this is already available on the US AMOC website. We identified priorities and items that we would like to finish or complete prior to the sunsetting of the US AMOC Science Team. And they were indicated as collaborations, priorities, legacy products, and communication. I'm not going to go over all of the details here, but I'm actually happy to say that we have already accomplished quite a few of these tasks that we identified for ourselves, such as writing white papers regarding AMOC observing system requirements. Actually, we did it also for modelers in Ocean Ops 19, just to give you an example. So along the lines of essentially listed here, we have one of our items was essentially have one last AMOC Science Team meeting. And because of the COVID, this got delayed. And there is actually quite a bit desire to have this meeting in person to get the full benefits of the meeting. So our last meeting of the science team will be in April, late April at Woodsall. And this is going to be both in person and virtual. So it's a hybrid meeting. At least that's the plan, unless, I mean, to my knowledge, it is still a hybrid and there will be an in-person component. Of course, the wild card is essentially if things change, then we need to go back to fully virtual. And I would like to just indicate that the abstract submission deadline originally was February 18th, but it's my understanding that there might be some extension of this deadline, and Jenny can provide that information at the end of my presentation. So one of the efforts that we pursued was creating an AGU virtual special issue. This was titled as Atlantic Meridional Overturning Circulation, Reviews of Observational and excuse me, Modeling Advances. The idea here, as just the title says, we try to sort of showcase progress in AMOC, particularly advanced by the US AMOC Science Team in collaboration with our international partners, as I said, in particular the UK RAPID program. And I'm quite happy to show you the the titles and the author list of these manuscripts. We have 9 manuscripts. These are already published starting in April 2019, and the last one was first published. This is online, I believe, in January of 2020, and they cover all the way from modeling to observations to theoretical modeling aspects of AMOC. So in early 2021, we published another JGR Oceans article. Mike and I were co-authors. This was led by Merrick, who is the the leader of the UK RAPID program, or at least at that time. And this was essentially intended to highlight the special issue manuscripts that were published. Following on that, and then also as part of our bucket list of things that we wanted to complete prior to the sunsetting of the program, we actually had AMOC webinar series starting in May 2020, and then continuing all the way to June 2021. We actually had the lead authors of those manuscripts present their main highlight findings or summaries. and you can see all 9 of them. There are actually 10th one here. One item that's missing in the special issue is a manuscript on paleoclimate AMOC and relationships to modern AMOC. And Hallie, one of the co-chairs of that working group, is leading a manuscript, and then she also provided an update on their work back in 2021. I would say that these webinars have been really quite successful. In total, all 10 webinars have been attended by more than 1,000 participants. So on average, we got more than 100 participants per webinar, but they're also recorded. You can actually access these from the US CLIVAR AMOC Science Team website, and then the recordings on YouTube. This is quite actually impressive. To date, have been viewed by more than 4,400 people, and this is literally less than 2 years from the beginning of the first webinar. I think this is a quite impressive number. So just a few science highlights. For those of you who may not be familiar with what's going on in the AMOC world, is that there is I will say relatively recent, but this is going back to sort of papers by Mike Spull and others in, I think, late 2000s. But it gained more momentum with the more recent observations called OSNAP. It stands for Overturning in the Subpolar North Atlantic. It's a relatively new observational array. It actually measures the overturning in the Labrador Sea region as the OSNAP West. And then there's another area all the way from the southern tip of Greenland all the way to Scotland that's essentially OSNAP East. And the plot here shows the time series of the overturning time series. The total is the black line, with the gray shading is some kind of uncertainty estimate for the full array. And then that's for the full array, both the east and west side together. OSNAP East is shown by the orange line here, and the uncertainty range is given by that orangish, sort of lighter orange color. And then the OSNAP West transport, overturning transport, is shown by the bluish, blue colors. So you can easily, and this is extended, it includes, I think, the most recent data sets all the way to towards the end of 2018 as well. So the message here is that overturning in the high northern latitudes is primarily dominated by what's going on, including its variability, in the OSNAP East side. That is not the Labrador Sea, but on this eastern side here. And this is in significant contrast with what the models are telling us. Models essentially most models, if not all, essentially indicate that what's going on in the Labrador Sea is the primary influence on AMOC variability and overturning. So this is actually in contrast with that. And that's why it gained a lot of attention. And then there have been quite a few papers essentially trying to dissect it in more detail, and perhaps there are more nuanced approaches. And then one study that actually that Steve Yeager led at NCAR is, this is just published, I think, in late 2021 in Science Advances. The argument here is that, yes, the overturning circulation in the east part may dominate sort of the mean or variability in short time scales, but what happens in the Labrador Sea, even though it's rather small, actually impacts AMOC overturning circulation more so. And for this analysis, high resolution 10th of a degree ocean model coupled to a 10th of a degree sea ice model was used. The top panels show the annual mean analysis. The bottom panels show the low pass filtered. I think we use either 10 or 15 year filtering. In the mean overturning, if you look at it, yes, indeed, this is at the OSNAP side. The black line is the total, west is the blue one, that's the Labrador Sea, and the east is the red one. Indeed, annual time scales, and if you just look at the overturning, indeed, the east dominates. But what matters more is what's happening actually in terms of the water mass formation or transformation. And this is shown here in density space, all of the plots in sigma 2. We see that the large, dense waters are actually forming in the model world in the Labrador Sea region. So you can see that the blue line is the dominant one. But if you actually take a sort of a time-filtered view, and this is not possible with the observations yet because we have only about 4 years of data. If you look at the time filtered view, low pass filtered, indeed, you see now more of an equal role for Labrador Sea and the eastern side and in the overturning circulation itself, but you still maintain the importance of the Labrador Sea water mass formation in variability associated with AMOC variability in the model. But this is by no means settled. I mean, there are still papers coming out on either side of the discussion. So another new effort is associated with the Hirans Map project. This was led by Malcolm Roberts. I don't want, I mean, there are quite a few plots in this study, but just interest of time, I just wanted to show a comparison with high-res and low-res model versions at the rapid side. These are all different, showing AMOC profile at 26 north at the rapid side. Black is the observations, and then each panel represents a different modeling system. This is Hadley cell model, I shouldn't say Hadley cell, Hadley center model, EC Earth, CNRM. Most of them are NEMO and European models. We participated with the CESM, high-res and low-res model versions. I mean, the general message is that the models are acting differently, whether low-res and high-res comparisons. So for example, EC Earth model here, there's not much of a difference in the representation of AMOC, whether one uses the low-res or high-res model version. When I say low-res, it's mostly 1 degree. High-res is of the order of maybe 1/4 degree to 0.1 degree. In our case, I mean, we see some difference. The lighter color is the low-res model, 1 degree. With high-res, we get something like this. Maybe one can argue we are closer to observations in that sense, but it's a mixed bag. In the MPI model, high-res, is the lighter color, and then the lower version is a bit the darker color, I believe. So it is a mixed message. Another project that I just wanted to mention is this is in collaboration with Eleanor and Matthias, Eleanor Freika-Williams and Matthias Lankhorst from, one is from the rapid, the other one is from the move side. We looked at essentially, this is part of the AMOC metrics project, looked at the pentadal, decadal, and multi-decadal trends at the move and rapid sides. In 2018, Eleanor and collaborators actually looked at the comparisons of sort of trends at the rapid and move sides. And at that time, they only used the data sets up to 2016 or so. So just by looking by eye, you can see, well, the trends are already shown here, while the move side, which is the black line here at 16 north, indicates that AMOC is actually strengthening at a rate of about 8 square drops per decade. The rapid side was showing actually a decline of maybe half the magnitude, but it's a decline. So in our AMOC metrics project, we tried to see what the models are saying, and what's shown on the right side is the time series of the 5-year, 10-year, and 30-year trends from the high resolution 0.1 degree ocean model forced with core data sets. That's the JRA 55, I should say JRA 55 data sets. And what I'm showing here is what I call model truth. At the rapid and move side, model transport based on actual model meridional velocities. And you can see that from 5 to whatever 30-year trends, you see that the both sides are actually matching better as you go to lower frequencies. And then in the modeling world also, the trends between 2004 and 2015 as square drop transport per decade for both rapid and move are in agreement. The model world is saying that there's a decline of AMOC by these amounts. But this is in contrast with what the observations are showing. As Eleanor and company indicated in this manuscript is that it is difficult to come up with a trend estimate at the rapid side. And what I'm showing here is if you just now focus on the blue line and the gray line here, those are both from rapid, from the model though. The blue line is essentially the total rapid transport, and the gray line is the contribution of the compensating flow, or the external flow, or the barotropic component to that transport. You can see that details of that barotropic transport computation, both in the model, but particularly in the observations, make a big difference, and they contribute a lot. That external component contributes a lot to the trend, particularly at short 5 to 10 year, maybe pentatable to decadal timescales. So that's what they actually concluded in their manuscript too. One needs to be careful with how the internal component, compensating flow is computed, and the details can matter at the rapid side. And we confirmed that thing also from the modeling world as well. And I'll just finish with this extended time series now. It's updated, I believe, all the way to the past middle of 2018. AMOC transport time series at 26 degrees north. This is from the rapid array. And in the interest of time, you can just sort of focus on the red line here. It shows the total AMOC transport all the way from early 2004 to mid 2018. So, many of us have seen many manuscripts talking about different segments of this time series, arguing that AMOC is collapsing or AMOC is recovering. But I guess if you view it from a almost 15-year window, one would be quite hard-pressed to say that AMOC is declining or AMOC is increasing. It is remarkably stable in the long term, with maybe occasional excursions, particularly in 2009 and 10 frame, and we know that was due to the winds. But especially since then, AMOC is rather stable, and maybe one can say, that's why I'm hesitant to say it's increasing at this point, but there's a minor, perhaps increasing trend. So with that, I'll just finish with some thoughts. Regardless of whether AMOC science team is going away or not, AMOC-related research will definitely continue after the sunset of the science team. Important elements of the science team that should continue include sustained observations, collaborations, coordination, and communication at both national and international levels. AMOC science team was, I think, in my view, was very successful starting new collaborations. That's why there's a desire to have these meetings in person, rather than just very informal and not very informative Zoom meetings. And it was actually quite important to start coordinations and better communication. I think this is going to be an important element to continue forward. It's important to keep the efforts focused and identify emerging and future research directions, and such as the emerging differences between the models and observations that I try to highlight here with respect to what's happening in the northern North Atlantic. And I think we need to move towards tighter coordination or better merging of observational modeling and data assimilation efforts towards more process-based understanding. But I fully recognize that that's easier said than done. And we have been actually, Mike and I, reaching out to international CLIVAR to make sure that some of these efforts continue. And as a result of our reach out, we have actually formed an AMOC task team under the CLIVAR, International CLIVAR Atlantic Regional Panel. We have actually membership and all that stuff, but I could not find it officially on the website of International CLIVAR, but it has been approved by the International CLIVAR SSG. And the idea is here to coordinate and continue some aspects of AMOC-related efforts. Of course, this body recognizes that they don't have financial power or anything like that, but they are, the idea is to continue, as I said, and coordination, collaboration efforts to the extent possible. With that, I'll stop and take questions, and thank you for your attention.
Great, thank you, Gokhan. So yeah, if you have a question, type into the chat box, or you can raise your hand. And also to clarify what Gokhan was saying about the US AMOC Science Team meeting, yes, we are extending the abstract submission deadline. So right now, the current deadline is tomorrow, but we will be extending that for 2 weeks. So the new deadline will be March 4th. and then registration will open following that.
Thank you.
So do we have any questions for Gokhan?
I should mention that, I mean, the highlights that I presented here is sort of self-centric in a sense that I'm familiar with some of the efforts. And as I tried to indicate that there are over 75 projects and they are quite impressive. And I should also said that the Jenny, as we speak, working on editing those reports that we received in our science team reports, and that is going to be quite good, and they're very useful for the community as well as agency managers as well.
So I see a question from Patrick.
Yeah, thank you, Gokhan. So my question is, it seems that those long-term measurements are really important. I was wondering what the status for those long-term measurements to continue, and then are there kind of additional measurements that are required to really provide that extra process study understanding that you talk about that we need going forward?
Well, the funding of I mean, Mike can chime in with more of this thing. Sustained funding of observational efforts has been challenging. Until very recently, the RAPID program was under the danger of basically their funding completely cut. And they were asked to sort of, well, can you do with only one mooring or two moorings or X number of moorings? It is my understanding, and then both Mike and I mean, try to essentially promote the importance of RAPID, for example. And I think that was, I mean, I don't think that we should take credit, but it maybe helped that it got extended a little bit more. But I don't think that it is, yeah. Let me finish there and then I'll let Mike. So that is there. And then Samba array I'm not sure exactly how much funding they have. And in fact, I was just at a meeting with the Samba folks, and they need, it looks like what we are finding with the AMOC metrics project, you need quite a few moorings to capture the AMOC variability. There's efforts at 11 South. There is move array, of course, we focused on too. That's at 16 degrees north, but that's partial. And then there's the 57 north, I believe, all of those arrays. And OSNAP is rather new, and I'm not sure how far it's going to go into the future, but I'll let Mike chime in now.
Very good question, really appropriate for our panels. I think that it's a nascent system, right? The rapid MoCA array has been out there for what are we up to now? We're going to get close to 20 years soon, right? Yeah. But that's the longest we have really the core of the in situ observing system. It has been funded largely by not sustained funding sources. Much of the funding that's gone into this observing system from the US side has been, there are components that are supported by NOAA, so don't get me wrong, but through NSF grants. And we had Line W, which people might remember was one of our only transects, reviewed transects through the Gulf Stream. I guess it was that provided us important information in that region that only after a 10-year project, I think it's 10 years, the decision by NSF in response to a physical oceanography panel review was, well, as a project, it's completed its work. And yet we were thinking in US AMOC that this is, and AMOC internationally, right, those working on these problems, is that that's an essential part of the observing system we're trying to build out. When for RAPID, what happened with the UK, which is really providing the backbone support, work through our MoCA effort. It's a collaboration, but without that support by the UK, it would fail. This 20-year record we would not have that continuity. But the problem in the UK is not that there's lack of interest of the science programs to continue, the scientists continuing it forward. It's that the organization that provides, like NSF, NOC, and their National Research Council, providing the support is saying, we're not in the business of sustained observations. We have science to support. And so the transition from a research-based funding to an operational system is one that's really challenging. We experienced this with The Tropical Pacific Observing System itself is JAMSTEC pulled out of the Western Array. So these, where one country is largely responsible for an effort like Line W, we can see it disappear because of where it's funded. And the international collaborations for support are really tenuous when one partner may be not a sustained observing system like we have for NOAA, but maybe a research base of support. So as we go forward, our sense in the US AMOC community over the last 14 years with this team is that we're just getting started on defining what this observing system ought to look like. Let's not see it fall away. And let's use what we have amassed to really make the case for what a future design will look like. And it's efforts like Gokhan and others who are working on the metrics to really evaluate what's needed and kind of testing what approaches are going to work, what the mix of moorings, the PIES instruments, the surveys, the use of gliders, and the mix of approaches, and what's the minimum needed even. We don't have that question answered. Well, and maybe we don't need rapid MOCA to be as heavily instrumented.
One thing that I was going to mention is that my understanding is that rapid was not going to be renewed for the after the first 5 years. That dip that I mentioned, because they told them that you are just measuring the seasonal cycle. That dip in 2009 and 2010 was the savior for the rapid program and to get funded for the next 5 years, because they argued that that dip was not part of the seasonal cycle in essence. So that saved them. But now again, the same arguments are coming back. And as Mike indicated, sustaining at a cheaper rate with fewer instruments is the push. And I'm not an observational person, so other people can chime in, but that's a big challenge that we need to overcome.
Shane?
So I guess we heard today, and I can announce that officially NSF is recommending the extension of the US funding for the next 5 years, right? So, we heard confirmation from NSF today, and myself and Bill Johns are going to be continuing this project for the next 5 years, but it's going to be a continuing award, which is contingent to the UK funding, right? So we are confident the UK funding is going to go through, but we're on board for the next 5 years, including exploring, alternative to the array to make it more streamlined, especially on the western boundary. So
I should have shut up because Shane is here from the reaction. Sorry, Shane.
No, it's okay. It's okay.
Just so I understand that point, Shane, UK has also committed for the 5 years too?
No, they have not, and I cannot talk on to them. But the NSF has confirmed a continuing award, which is contingent to the UK funding.
Yes,
right?
yes, I understand that. But the nice thing is that it can play the other way too. I think, that's kind of how we can position these things, that the US is investing now and the UK scientists can help that to leverage the decisions there. But we still have, I think, this is true for all of our observing systems, that as we're building them out, we're resource poor on these. And who's to say that rapid's over instrumented, that it needs to be less? We can do the analysis, but the drive to always do more with less. So we stretch it as pieces of it fall away. That's what gets me, that we have to be vigilant as a community to really make the case of the importance of it, not only to the science, but the impacts of on climate and the importance of these investments over in a sustained way is really important. And OSNAP is a design experiment. It was set up like that. They purposely went out to see what they needed to measure. So at some point after one extension, right, they've got a second round on that effort. They're going to have to, the way it was posed, they have to come back with what they think the design ought to be for sustaining and make that case. And our only hope for all of this really is that our agency responsible for sustaining observing, it's not for a lack of desire on the part of the managers.
Well, that was
ability to get the funds. If we can figure out as a community how we bridge this transition between research arrays into sustained observations from one agency to another and keep things alive over in the research agency, the science agency, until we can make the case for operational investment, we're going to see things fall away. And I'm nervous about this next period, and that all of this effort for these international collaborations that make it happen can start to tumble.
Yeah, I'm personally worried about the OSNAP because based on our discussions in last in-person meeting at the Ocean Sciences with the executive committee, the funding agencies were indicating that, I think it's consistent with what Mike just said. There was the first phase of the OSNAP, and then they have the extension now. They are sort of in the second phase, but what happens after that is not guaranteed. In fact, the funding agencies, I think, indicated that there may not be continued funding of some sort. But I think, as I was trying to make the case here, is that we need to know what the long-term changes are, right? Because if we want to essentially improve the credibility of the models and all that stuff, we need to have long, sustained observations. So that's it.
I have another quick question for you, Gokhan. How do you foresee, especially with this coming to an end of the science team, the role that our panels might play in making this case, both for the observing system and the tying back of our modeling needs and our understanding of predictability and process representation within the models and all that improvement? How do you see US CLIVAR panels playing a role in this post-science team era?
Yeah, I mean, that was my concern initially too. We partnered with the for advocation and collaboration or coordination with the AMOC, CLIVAR Atlantic panel. But within the US, and since US funding is so important, as just Shane, just highlighted right now for these observations, I think we need to somehow make sure that the US CLIVAR panels, panels, I guess. I know that they are considering the entire globe, but we need to make sure that somehow they advocate for coordinated activities with observations, coordinated activities with the process level. But I feel like I shouldn't say this perhaps, but we for the US AMOC Science Team, in a sense, it was serving as a cross-cutting entity, in a sense. It was bringing observations, modeling, and other aspects and analysis in a way that's tighter than possible in a siloed approach. So when we advocate for more observations, we need to make sure that they are not just for the sake of getting more observations, but it has to relate to processes that we want to understand. And that would essentially advocate for more, and I think that's part of the, summit, and maybe more meetings among the panels, across panels may be needed to advocate or improve that. I don't know whether that's a deficiency or not, but that was one aspect that I'm worried about with the disappearance of the AMOC Science Team. That sort of cross-pollination and cross-discussions we need to continue, and also with a focus on AMOC probably at the US CLIVAR level as well. So,
something that what that question and Gokhan's response made me think of is, I don't know how well agencies, the way we fund things right now, are really. It's what's important to do this is to be able to have models and observations. As Charlotte and I talked about a lot last year, is to get them to talk together better. But we need to do that before we have the field data, right? It's more like an observation system simulation experiment, and having that at the front end so we can better understand the observations we need. I just don't think that that's always like the focus of some of these funding efforts. And maybe there's something we can do with cross-panel kind of coordination or whatever, but to raise that as something that we need. We can presumably better identify the processes and how the observations that we need to go out and better understand them if we had more observation and models coordination up front and funding for that. Because that's the thing, is we all want to do it, and I think we've all said like that has to be done, and we've seen that in some of our recent process study webinars about how just by chance some extra simulation experiments happened during CPEX AW just because of the COVID delay that ended up helping them but that's not often the way it is. And so I think more of a focus on funding that type of activity could really help us better identify the observations we need to verify our models and improve our understanding before we go into the field.
I mean, along the lines, maybe I didn't stress it enough, but are those reports that I highlighted, and we are working on the next report, on final report right now, we essentially put in sort of future directions and recommendations. And Mike and I draft that thing based on what we get from the sort of meetings. And funding agencies, and correct me if I'm wrong, Mike, pay attention to that. In other words, maybe we can actually help US AMOC Science Team sunsetting, but also help US CLIVAR in that sense for the coordination in a sense. If we make sure that certain activities are listed for future as recommendations and for collaborative activities. And I know that certain calls come out based on those. So I think we can help each other in that sense. And Mike can chime in with that. If,
That's an excellent idea and a good thing to, on these meetings, often you go into those breakouts where we're going to be discussing about future priorities with some seeds to plant, right? And so this would be a good one for those discussions.
So I think we have a lot of good discussion that we can bring to the summit. Also a lot of AMOC related discussion that if we see you at the science team meeting would be really beneficial to capture. So I did drop a link to the meeting in the chat. So if anyone wants to submit an abstract, that link will send you to the form. So thank you again, Gokhan, for giving us a presentation and update on the US AMOC Science Team. Next week, we'll have 2 more webinars to round out the pre-summit webinars. One will be covering the data science working group, and the other one will be covering the air-sea interactions working group. So that one will be on a Wednesday and Thursday, respectively. So I hope to see you guys all there. Thank you, everyone on the line, for joining today, and I hope you guys have a great rest of the day.